Hi students, so today we are going to be setting up a lab to experiment with Newton's laws. So the lab materials you need are two lifesavers, string, you'll get a piece of cardstock, a ruler to measure with, and then you need something to record your data. So we have a data table all printed out and our writing utensils. So you'll need your science notebook to collect the data in this case. So to set up this lab, we're going to be actually changing our independent variable twice. So one of our independent variables is going to be mass, and we're going to change that with the number of lifesavers we're using. And our other independent variable will be acceleration, and we're going to change the angle that we put the string off the table. So let me show you how we're going to do this. We're going to set up our string so it's on the side of the table. We're going to tape it on here, or you could put a heavy book or whatever you have on so that the string is dangling from the table and the lifesaver is almost touching the ground. Then you're going to take a piece of paper and you're going to fold it hot dog style, so the long way. You're going to fold your paper like that, and we're going to set this paper right here in the same spot every time so that we can see how much those lifesavers, when we swing this string, are going to move that paper. So we have our data sheet here, and our data sheet has 10 trials. So remember, when we do an experiment, we want to always have at least 3 trials. The more trials we do, the better. So as we do these trials, we'll measure how far the paper's moving from its original spot using our ruler, and then we'll write that distance in centimeters on our data table. So here we go. Our first trial, we're going to pull the lifesaver back all the way to 90 degrees. So when you look at the side of the string over here, you want it to look like a right angle. Okay, a perfect right angle. So here we go. Here's our paper set up in the same spot, and we're going to lift it up at a right angle and let it go. And then we're going to see, like, I don't like how this paper just moves sideways like that, so I'm just going to give it another run and see if I can just get the paper to move so it's easier to measure. So here we go. I'm going to let it go. Oh, that's much better because I can see clearly how the paper moved. So if I measure from where it was, that's at 13 centimeters. So I'm going to write a 13 right here in my data table. 13 with our one lifesaver. And I'm going to keep doing that, and I'll keep writing it in for each time I do that. That one wasn't quite as far. That went 10 centimeters. Remember, we always want to use our units so it's clear what we're measuring. I'm going to reset up my trial again, hold it at 90 degrees. And that one is at 11 centimeters. And again. And that one's right at 13 centimeters. And here's trial number 5. That one really did not move very far, 7 centimeters. Trial number 6. That's 12 centimeters. Trial 7. That's 9 centimeters. That is 9 centimeters again. And remember, always at a 90-degree angle with our one lifesaver. And that's at 11 centimeters. that's right about 10 centimeters. Okay, so that's with our one lifesaver. So we have all of our trials are written down. We're gonna add these up to get the total, and then we're gonna divide it by 10 to get the average. So we're gonna go ahead and start collecting for our two lifesavers, and all you have to do for that, you just take your string and tie on the other lifesaver. That might be a little bit tricky, but it doesn't matter as long as it's on the end. So again, this is to change the mass. That's our independent variable. In this case, we're going to change the mass by adding another lifesaver. I'm going to get it tied on here. Maybe. Okay, so here we go. We're going to run 10 trials again with two lifesavers. We're going to collect that in the same way, meaning I'm going to pull it up to 90 degrees again. And remember, that's going to be like a right angle on the table. And here we go. Okay, that's right at 18. I'm going to write that in trial number 1, 18 centimeters. Okay, and that was 22 for trial number 2, 22 centimeters. Trial number 3, I have 21 centimeters. Now that's 20 centimeters for trial number 4. And that is 18 centimeters for trial number 5. And that time the paper kind of went crazy, so I'm going to do that one again because I don't think that was going to give us very good data. So we're going to redo that trial. That's putting us clear at 25 centimeters. And we're on trial number 7. That's 22 centimeters. Oops. I didn't quite get my paper that time. Can I do it again? That was better. That's 22 centimeters as well. Oops. Here we go. That's at 23 centimeters. That's at 22 centimeters. So now I've completed all my trials for one lifesaver, and then we changed the mass. Here's 2 lifesavers, and so we have 10 trials for each of these independent variables. Now we're going to change the acceleration. So we're going to go back to just using one lifesaver, and we're going to put it, instead of being at the 90-degree angle, we're going to put it at a 45-degree angle. So the way we're going to do that, take off our other lifesaver. 45-degree angle is half of a 90-degree angle. So it looks like a triangle when you look at the table. So if you say 90 degrees is here, 45-degree angle is going to be there. So we're going to do that 45-degree angle with one lifesaver. And here we go. Oops, that one's stuck to my hand. Let me try that again. Okay, 45. Okay, and that moved it about 2 centimeters. So I'm going to write 2 centimeters here on my data table for trial number 1, and I'm going to continue that 9 more times at a 45-degree angle. was 3 centimeters. And I am just estimating that angle. If you have something to measure that, like a protractor, you could totally measure it. Or if you try, like you could put a piece of paper with a mark, but I'm sort of eyeballing it, which is good enough for what we're trying to do. Okay, that was 4 centimeters. So now I'm on trial number 5. And again, the more trials we can do, the better, because when we get a lot of data, then we can divide that and get the average, and so it's much more accurate. There we have 3 centimeters. And because we're super sciencey, we always measure in centimeters, because that is, well, centimeters or meters or anything in the metric system, because that's the universal language of science. We don't use inches and feet typically, because other scientists in other countries don't use those same measurements as we do here in America. Okay, that one was actually 5 centimeters. Now we're on trial number 8. That was 4 centimeters. That was 3 centimeters. And one more trial, because that was trial number 9, so we're going to do one more. 45-degree angle. And that was just 2 centimeters. Okay, so now we've done 10 trials of 45-degree angle, and remember we just had one lifesaver on it. And we've already collected the data for the 90-degree angle, because that was our first column. So I'm just going to move this data, because this column is the same as this trial that we're going to do. I'm just going to move this data from here to here. So I'm basically just copying it over, because that is the same data that we're wanting for these trials. So I'm just swapping it over. So see, from 13 over here, I'm going to write 13, and then here's 7. I'm going to put 7 centimeters over here. There's 12, and the next one's 9 centimeters and 9 centimeters, and then here's our 11 centimeters I'm putting over here, and our 10 centimeters. Okay, so now what I'm going to do is I'm going to calculate the total, and then I'm going to divide that by 10 to get the average distance that this card moved. And that'll give us a good indication of if we kept repeating this over and over, that we would get about this amount each time we did it. So I'm going to add up all these numbers in this first column for the one lifesaver. So I'm going to go 13 plus 10 plus 11 plus, here's 13, plus 7, plus 12, plus 9, plus 9 again, plus 11, plus 10. And then I press equals. So I have 105 was the total, 105 centimeters. And then I'm going to divide that total by 10, because we did 10 trials, and that gives me 10.5. You know, we could just move the decimal, but I put in my calculator, and that's totally fine too. So we have 10.5 centimeters is the average distance it moved when we had one lifesaver on there. Now for you, you need to do the same thing for these columns. So you'll add up all these numbers in this second column. You'll get the total. Then you'll divide that total by 10 to get the average. That'll give you the average distance the card moved for 2 lifesavers. The same thing over here on this third column. You'll add up all these numbers. That'll give you the total. You'll divide by 10 to get the average that the card moved when you had a 45-degree angle on your string. And then we know this column has the same data as this column, so we can just transfer those numbers over there. 105 centimeters, and then the average was 10.5 centimeters. Now we're finished collecting our data. What you need to do is go into Canvas and finish answering the follow-up questions for this lab.